During the golden age of Soviet helicopter development, while the Mil Design Bureau was constantly setting new world records with its giant helicopters, the Kamov Design Bureau was exploring a completely different technological path. Their goal was to create an ultimate aircraft that would combine the strengths of both airplanes and helicopters. In a single machine. In 1951, during a meeting held in the Kremlin, the Kamov Bureau failed to secure the project for a new transport helicopter. To recover from this setback, Chief Designer Kamov proposed a new high-speed aircraft with a compound configuration, which he referred to as a gyrodyne-type machine. At first, the design team even considered simply mounting their well-proven coaxial rotor system onto a conventional transport aircraft. However, this idea was quickly rejected. After many rounds of weighing different options, they finally settled on a more feasible layout. Separate power units, lifting rotors and pusher propellers integrated into one system, installed at the two tips of the wing. For the Kamov Design Bureau, which until then had focused almost exclusively on coaxial rotor designs, this was an unprecedented challenge. To turn this bold concept from drawings into a real aircraft, Kamov spent a great deal of time lobbying and arguing his case. In 1954, under the same government decree, the task of developing a heavy-lift helicopter was also assigned to Kamov's team. This was how the project designated Ka-22 officially began. To support such a groundbreaking program, the authorities even issued a special order to transfer a factory in Yukhtomsky to Kamov. The Kamov Design Bureau then moved its headquarters there as well. The aircraft itself was a true giant. It had two main rotors, each 22.5 meters in diameter, mounted horizontally at the tips of the wings. A complex RPM control system connected these rotors to two pusher propellers, allowing power to be managed and switched between them as needed. In high-speed level flight, the wings were intended to carry most of the lift, while the tail surfaces at the rear further enhanced stability. Inside the enormous fuselage was a cargo bay nearly 18 meters long. Depending on the mission profile, it could hold up to 80 soldiers or carry about 16.5 tons of cargo. Many of the Ka-22's design features were completely new in the Soviet Union at the time. Its compound propulsion system, the unconventional rotor layout, and the highly complex control system all pushed the boundaries of what contemporary aviation technology could handle. To tackle these technical hurdles, the Bureau built a variety of dedicated test stands, and research institutes from across the country were brought in to provide support. In June 1957, Mil's Mi-6 began its own flight tests. Just 4 months later, this massive helicopter successfully lifted a 12-ton payload to an altitude of 2,400 meters, doubling the previous world load-carrying record held by the American S-56. Western media widely reported that this new Soviet giant was so powerful it could practically lift their biggest helicopter into the air, flag and all. Development of the Ka-22 started around the same time as the Mi-6, but it did not achieve its first free-hover test until June 1959. Its extremely complicated control system meant that the test pilots needed a long time just to learn how to fly it properly. When the first full flight test began in April 1961, a host of hidden technical problems finally emerged, and the design team was forced to implement a long series of modifications. They went as far as swapping out the engines and gearboxes and even reversing the direction in which the rotors turned. The belief was that these changes would improve handling and make the aircraft easier to control. Because of this, flight testing was paused for a time so the team could carry out long, painstaking adjustments to the aircraft systems and components. After a great deal of hard work, the Ka-22 finally seemed to be tamed. In the summer of 1961, it made its first public appearance at the Soviet Aviation Festival. That same year, it went on to set 8 world records in speed, rate of climb, and lifting capacity. With a top speed of more than 350 kilometers per hour, it left every other helicopter of its era far behind. But beneath this brief moment of glory, the inherent problems of its compound design quickly began to surface. In later flight tests, serious stability and control issues led to the loss of 2 prototypes. claiming the lives of their crew members. Even though the program's future was already uncertain, work on refining and tuning the Ka-22 continued for a while, simply out of momentum. On the basis of what they had learned, the design bureau even sketched out several new aircraft concepts that used similar compound layouts and showed promising potential on paper. By that time, however, the military had largely lost interest in such a complex machine. Most of their transport needs were already being met by the Mi-6 heavy-lift helicopter, which was not only reliable in performance, but also entering large-scale mass production. Although the Ka-22 offered a more spacious cargo bay than the Mi-6, it did not deliver a clear advantage in speed. Its extreme design complexity completely overshadowed the modest benefits it could provide. More critically, when operating at heavy loads, the Ka-22 had to perform a rolling takeoff like a conventional airplane. This severely undermined its core value as a vertical takeoff and landing aircraft. The designers had hoped to combine the strengths of both airplanes and helicopters, but reality dealt a harsh verdict. Instead of adding their advantages together, the aircraft ended up amplifying their weaknesses. Faced with these practical constraints, the Soviet leadership ultimately decided not to put the Ka-22 into mass production. Once the project was officially terminated, the remaining prototypes were dismantled. This machine, which had briefly stunned the world, ended up leaving only a wistful footnote in the history of aviation.